Alright, everyone, March 16th. Contiguous array. A binary array return the maximum length of a continuous subarray with an equal number of 0 and 1s. Equal number of 0 and 1s. Which just means the sum will be half the length, right? Which just means maximum length. Which just means we want to find a max length so if we have a prefix sum ending at every single position, I have a sum, and then I have the previous sum at every single position, and all I want to see is if the difference between the two, the difference between the two will be half of the difference between the indices, right? Indices. Well, how would you tell? Well, if I'm at a certain position and I have a certain value, right? So if we have a prefix sum, we have a P0, P1, P2, P3, right, all the way down. And I'm at PK. So what I want to find is some index, I call it I, such that PK minus PI, right, PK minus PI is the sum of these things. And then K minus I is the length of this thing, right? The length of this thing. So I want the sum of this thing equals to half, or 2 times the sum of this thing, or equal to this. Now K is something I know. I and PI I do not know. So what I can do is I can compute 2pk minus 2pi shall equal to k minus I, or we can say 2pk minus k, this is I know, equals 2pi minus I, right? So basically I have this value, I just need to compute this value for every single position. I compute this value for each of this. I try to see if the one of this, if this exists, right? If this exists, and if it might have multiple of this exists. So when we find it, we need to find one with the smallest, right? I want to find one with the smallest. So basically we can put this as a map, and then we have an array. Actually, we don't even need to have an array, because I just need to record the first time this one occurs. Whenever we find it, that will be the answer. So I just need to find a way to represent. So it's going to be a map. All right, we're going to use a map. We are going to use a map. Okay, I'm gonna call it minimum. I'll call it M. Okay, and then for we need also rest shall equal to 0. So we want to find a maximum, right? Maximum length. Then we say current should be 2 times, oh, we also need a prefix sum, p sum, okay. Right, so p sum plus equal to nums I. Current should be 2 times p sum minus I. Right, and then if m dot contains key current, if it does not contain, then we can say m dot put current and the index. Right, if it exists, if m is already in it, then we simply do res equal to maximum, res and the current I. What are we returning? The length. Yeah. So it'll be I minus m dot get current. Right, m dot get current. At the end, I'll return res. So the last one. Because it doesn't exist before. All right, because it doesn't exist before. Yeah, because at the end we have p sum is equal to 1, and 1 does not exist, so I put it in. Yeah, how do you deal with this? Anything else, it's fine. It's just like pi is equal to 0. Right? We have an extra. Right, we have an extra. So in that case, we might have to set something at the beginning. Pi minus this equal to k minus so this is 1, 0, and then k is 1. I should be minus 1. So what? We put 0 in and give it a minus 1. How's that gonna work? Because you go to the end. What's the end? Oh yeah, I shall do that. We shall do m dot put 0 should be minus 1. Right? You put 0 minus 1. That is not right. It should be 2 times pi 0 minus 1. Should be minus 1, right? Should be minus 1. No. Wait, hold on. 2 times 0. No, it should be 1. Yeah. This is for the initial condition where pi is equal to 0 and I is equal to minus 1. Because 2 times pi minus 1, right? So that's the one. Okay, use prefix sum. We have for any index k, we want to find some index I such that 2 times pk minus pi equals k minus I. So this one give me 2 pk minus k, so equal to 2 pi minus I. Alright. Thus we keep track of the first index that, for each 2 pi minus I. Okay. Then for each 2 pk minus k, we use the stored indices of the same value 2 pk minus k to find the max length of subarray that satisfies the requirement. We proceed to find the max of all lengths. Okay, let's hope this one works. It does. It does work. Okay, this one has an official solution, brute force. Extra array. What is this method? Make a count variable. Relative number of words encountered so far while traversing the array. The count variable is incremented by 1 for every 1 encountered, and the same is decremented by 1 for every 0 encountered. We start traversing the array from the beginning. If at any moment the count becomes 0, it implies that we've encountered equal number of zeros and ones from the beginning till the current index. Not only this, another point to be noticed that if we encounter the same count twice while traversing the array, it means that the number of zeros and ones are equal between the indices corresponding to the equal count values. I think this is exactly the same idea as mine. They're just using a different way of expressing it. They're using count. Right? They're using count. To AB and BC and AC. Yeah, you're recording the first time you count at every single thing, right? You record the first count. So 0 count is this minus 1, so you record this minus 2, it reaches here. And then go back here. So isn't these two also, right? It's 0, 1, 2, 1, 2, 3, 0, 1, 2, 3. Actually, that's not true. AB. Wait, what's AB? It's this. No? This is good. Right? Oh, we start from here. So that's the first one. Minus 1. This. And minus 1. Minus 1, so we go 2. And then go up. Yeah, so these two are this. Right? Minus 1. And then these two are this. Right? And then these two are essentially this. And this has to go all the way to here. So 1, 2, 3, 4, 4. Yeah, so it's the same idea. So we use this plus minus to do this. It is the same idea. I could have using, but it uses this, so it's not really. Oh yeah, hash map. Hash map works as well. It's the same idea, so it's all right. Okay, yeah, we're done with this. You want to do this? Honestly, not really. Don't have much desire. Okay, well, I'll call it a day then. Again, we know how to, we have an idea how to do this, but I just couldn't find a gana. Every day is just getting later and later. I'll see you guys tomorrow. Adios.